So we have matrix D and matrix B, and they ask us, is DB defined? Is the product D times B defined? So D times B is going to be defined is if, let me make this very clear, and this is how I think about it. So let me copy and paste it so I can do this on my scratch pad. So to answer that question, get out a scratch pad right over here. Let me paste the question right here. So let's think about these two matrices. Let's think about these two matrices. You first have matrix D. I'll do this a nice bold D here. And it has 3 rows and 3 columns. So it is a 3 by 3 matrix. And then you want to multiply that times matrix B. Matrix B is a 2 by 2 matrix. The only way that we know to define matrix multiplication is if these middle two numbers are the same. If the number of columns D has is equal to the number of rows B has. Now in this case, they clearly do not equal each other, so matrix multiplication is not defined here. So let's go back there and say no, DB is not defined. Let's do a few more of these examples. So we have a 2 by 1, you could view this as a 2 by 1 matrix, or you could view this as a column vector. This is another 2 by 1 matrix or a column vector. C plus B defined. Well, matrix addition is defined if both matrices have the exact same dimensions. And these two matrices do have the exact same dimensions. And the reason why is because with matrix addition, you just add every corresponding term. So in the sum, the top, it'll actually be 4 plus 0 over negative 2 plus 0, which is still just going to be the same thing as this matrix up here. But what they're asking, is this defined? Absolutely. These both are 2 by 1 matrices. So yes, it is defined. Let's do one more. So once again, they're asking us, is the product A times E defined? So here you have a 2 by 2 matrix. Let me copy and paste this just so we can make sure that we know what we're talking about. So get my scratch pad out. So this top matrix right over here. So matrix A is a 2 by 2 matrix, and matrix E, so we're going to multiply it times matrix E, which has 1 row and 2 columns. 1 row and 2 columns. So in this scenario, once again, the number of columns matrix A has is 2, and the number of rows matrix E has is 1. So this will not be defined. These two things have to be the same for them to be defined. Now, what is interesting is if you did it the other way around, if you took E times A, let's check if this would have been defined. Matrix E is 1 by 2, 1 row times 2 columns. Matrix A is 2 rows times 2, or 2 by 2, 2 rows and 2 columns. And so this would have been defined. Matrix E has 2 columns, which is exactly the same number of rows that matrix A has. And this really hits the point home that the order matters when you multiply matrices. But for the sake of this question, is AE defined? No, it isn't. And so we can check our answer. No, it isn't.